Today we discuss about photochemistry. Photochemistry is the study of the interaction of electromagnetic radiation with matter, resulting into a physical change or a chemical reaction. Okay, here interaction of electromagnetic radiation with matter. The visible and UV radiations, nearly 200 to 800 nanometers wavelength, are mainly used in photochemical reactions. Far UV are used for water purification and lab equipment sterilization. UV radiations are used in drug detection and printer inks. Visible radiation helps us see and perform visible spectral studies. Essential criteria for all photochemical reactions. Molecules must absorb light for a photochemical or photophysical change to occur. Ultraviolet and visible radiation interacts with matter which causes electronic transitions. Electron transitions means promotion of electrons from the ground state to high energy state, that is excited state. Radiation energy must match energy difference of ground and excited state. So here electron excited from ground state to high energy levels. The energy difference is equal to the radiation energy. Process studies under photochemistry. Photophysical process. Those processes which take place in the presence of light but do not result into any chemical reaction. Here photophysical. Okay. Examples are fluorescence, phosphorines, and photoelectric effect. Okay. First one, what is that? Photophysical process. Here physical change takes place. There is no chemical changes. Photochemical process or photochemical reactions. Those reactions which takes place by absorption of light by reacting substances. Here absorption of light takes place. Reactions are brought about by the absorption of light radiation of the visible and UV region. Examples: photosynthesis of carbohydrate in plants, combination of H2 and Cl2 to form HCl. These two are photochemical reactions. These reactions occurred by absorbing light. Okay, these are the differences between photochemical and thermochemical reactions. Laws of governing absorption of light. Here Lambert's law. This law states that decrease in the intensity of monochromatic light with the thickness of the absorbing medium is proportional to the intensity of incident light. That is minus di by dx is equal to ki. Okay, simply decrease in intensity of the monochromatic light with thickness of the absorbing medium is proportional to the intensity of incident light. Second one, Beard's law. Same it is also here. Decrease in intensity of monochromatic light with the thickness of the solution is not only proportional to the intensity of the incident light but is also to the concentration of the solution. Okay, these are the two laws. One is Lambert's law, other one is Beard's law. Some commonly used terms here. These are the very important fundamental concepts actually. Transmittance T, the ratio of intensity of the transmitted light from the solution to the intensity of the incident light. T equal to I by I naught. Okay, that is I by I naught. Absorbance A or optical density D or extinction E. The logarithmic of reciprocal of the transmittance, that is log 1 by T or log I naught by I, is called absorbance. It is also called optical density extinction. A or E or D is equal to log 1 by T, that is equal to log I naught by I. Specific extinction coefficient Ks. It is defined as the extinction or optical density or absorbance per unit length and unit concentration of the solution. Okay, molar extinction coefficient minus log I by I naught is equal to minus log T, that is equal to A or D. Laws of photochemistry. These are also important questions for your UG level exam. Grothus-Draper law or first law of photochemistry. When light falls on a body, a part of it reflected, a part of it transmitted, and rest of it absorbed. It is only the absorbed light which is effective in bringing photochemical change in the molecule. The above law, however, does not imply that the absorbed light can always result into a chemical reaction. Stark-Einstein law or photochemical equivalence or second law of photochemistry. Every atom or molecule that takes part in photochemical reaction absorbs one quantum of radiation to which substance is exposed. Energy absorbed by 1 mole of the reacting molecule will be given E is equal to NH nu, where H Planck quantum, Planck constant, and Avogadro number. Values of Einstein in different units in CGS, in SI units. Here I clearly mention the values. Just check once. Quantum yield 5. The number of molecules reacting in given time, the number of quanta of light absorbed by in the same time. Otherwise, the number of moles reacting in a given time by number of Einsteins of light absorbed in the same time. That is called quantum yield or quantum efficiency. If the reaction obey the Einstein's law, one molecule is decomposed for one photon, then quantum yield is equal to 1. When two or more molecules are decomposed per photon, then quantum yield is more than 1. So here quantum yield, how many photons are absorbed and how many molecules are reacted. Okay, thank you. This is the photochemistry. Once I am repeating you slide by slide. Photochemistry, it is study of interaction electromagnetic radiation. First, second slide, third slide, fourth one. Okay, this is the fifth one. And laws, commonly used terms, laws of photochemistry, values, quantum yield, etc.